How to start webinar and share screen. And we are up and running. And people are starting to join.
Very good.
I discovered the other day, Bruce, what happens if my home Wi-Fi drops out in the middle of a webinar.
Oh, yes. And is it not
That was
helpful?
an exciting moment for me. My heart rate increased slightly. Well, it turns out that what happens is, because my speaker for that topic was in full flow, nothing happened as far as he was concerned. He kept going. The webinar kept going. Nobody, I think, even knew that I had dropped out and come back. But my problem was that when I got back in, I couldn't see any of the Q&A or any of the chat that had happened before I joined.
Oh.
So we got to the point of doing the Q&A and I had to say, I don't know what questions we've got. Could somebody post them in the chat for me?
I had a good bit of IT interruption the other day, and that was just before a long conference call I was meant to have. The postman pushed a long package through the letterbox, knocked over a vase of flowers, pushed over the BT router, and then the vase emptied its contents onto the router, which promptly died.
Oh dear.
And no amount of leaving it in the airing cupboard to dry out was going to help. So I had to get another router and set it up the next day. I had to leave the house and go back into the office to get some Wi-Fi to have a conference call.
Oh dear, I hope that doesn't happen today.
No,
it can't happen twice, can it?
No. But, yeah, that was fun. And I watched it happen as well, because I could hear the noise at the door, saw it happening, and it was one of those slow motion disasters, you know. And I could just see the glass vase going over and the router on the floor, and it just pouring gently into it. So, you know, that's first world problems of the highest order, isn't it?
Right, how are we doing? We've got 24 of us so far. I think I'm expecting about 55 if everybody came. For those of you who are here already, if you want to find the chat box and write in the chat your name and where you're joining from, that would be lovely. It's always great to see the roles that people, the hats that people wear that bring them to these webinars. Hello, Pete, first to type it in, Archdeacon of Liverpool Diocese. Hello, Graham. How are we doing? Just looking for the time. Another minute before we're due to start. Church wardens from Leicestershire and Somerset. Vicar from Driffield. Leeds Diocese, Suffolk Diocese, Gloucester Diocese. Hello, Kate, familiar name, just popped up in the chat. This is one of my favourite bits of the webinars, just seeing in the chat where everybody's joining from. So please do put your name and your role in there. Right, that's 12 o'clock. I do like to start promptly, so let's get going. Let me remember to hit record up here. Oh, we already are. Lovely. Welcome, everybody. Welcome to our webinar on the effective management of church lighting towards net zero carbon. As you know, I think I always begin my webinars with the upcoming attractions. So to let you know that we've got our two topics, we've got twin webinars on church heating because there's too much to say in one session. So we've got the two topics. The first is to replace or not to replace. And the second is on if you're going to replace, how to choose the right heating system. So those are two really useful sessions if you've got church heating that you're thinking might need replacing in the next few years. Please do come along. there's another run of the webinar you're about to come to on the 11th of May. So if you get to the end of this session and think, oh, I really wish that my colleague had been there, there's a chance for them to come along. And an early trailer of the fact that the first full week of June, we've got a whole series of land and nature webinars to tie in with Church's Count on Nature week. So there's 12 topics and lots of really interesting sessions there. I'll put the links in the chat when I've finished welcoming you, and hopefully you can find something of interest in there. Housekeeping. Because there's reasonably large numbers today, we're going to use the Q&A rather than the chat for gathering your questions. So if you've got a question as we go along and it's not answered in the slides, please do put your question into the Q&A, and you should find there a little thumbs up sign so that you can vote for other people's questions if you think they're interesting. And the ones with the most votes will rise to the top, and that's where Bruce will focus his time at the end when we get to the Q&A. And after we finish today, I will email everybody the slides, and I'll also send you any links that get put in the chat, and I'll send you a link through to our feedback form, and it's really helpful if you can click through and fill that in. Right, the main attraction. You're here to hear from Bruce from Light Perceptions, Bruce Kirk, a very, very experienced church and cathedral lighting designer. Am I remembering rightly? It's something like 300 churches that you've done the designs for?
That's about right, yes. Yep.
And also 25 years as a DAC advisor. So you're in very safe hands with Bruce today. I think with that, I'll stop sharing my screen and hand over to you, Bruce, to share your screen and take us away.
Catherine, thank you. Good afternoon, everybody. I'm going to go through the slides today and talk about the key elements that help the management of lighting towards net zero. Some technical, some not so technical. I hope it's going to be of interest, and look forward to picking up on questions at the end of the session, for which hopefully there will be a good 20 minutes to do that. So I'll press on. You will all get, as Catherine says, you will all get content of the slides. So I'm not going to read out all the text, but I will highlight the key points as we go along. So the important thing, just to start off with, is that just want to stress that we all use light in many, many different ways, at home, on the move, on a bicycle, in our cars, train station, at work, in the shops, at leisure, for those that can remember them, restaurants, bars and cafes, and of course in our places of worship. And all of the above need light of the right intensity, the right colour and contrast levels to be effective. But our understanding and appreciation of light has been transformed by some spectacular leaps in technology. So indulge a little history here, but I think the background is very helpful. This illustration shows wonderful history of light sources through the ages, going back some 70,000 years to flaming torches, oil lamps from 4,000 years ago, simple candles 3,000 years BC, argand lamps from the 1800s, and a flashlight from the 1900s, very early developments of artificial light. Obviously the sun is at the start, fire was generated from that, and we used fire to create torches for light. And light was invented as a tool used to extend natural daylight in spaces where the sun's rays didn't penetrate. So it extends hours of use in places where natural light is not always available. The origins, of course, of control of fire. It's much debated in terms of dates, but the first widely acknowledged evidence of the use of fire as light is thought to be about 400,000 years ago. And whilst humans have only used light for many, whilst humans have used light for many thousands of years, electric light, of course, is only a little over 200 years old, with the first arc lamps being demonstrated in the early 1800s. It took 100 years longer for filament lamps to emerge, and a little longer for electricity to be available in our homes and buildings to use them. So in the last 100 years, the changes in lighting technology have been as exciting as any other form of technological advancement. And today, our expectations of artificial light are far different from those in decades past, when the technology was neither as sophisticated nor as readily available as it is today. Today, Lighting Talk is all about LEDs, but let's take a quick look at how we've come to this point. So the first commercially available mercury vapor discharge lamp, turn of the century, 1901, tungsten filaments a few years later, and the first public use of neon lighting in 1910. The metal halide lamp came a couple of years later, and then gases were added to light bulbs in 1913 to make them a little bit more efficient, a bit more stable. The orange sodium vapor lamp in 1920, just over 100 years old now, and the first fluorescent lamp in the 1920s, and the first LED, believe it or not, in 1927. And then into the second half of the 20th century, the first halogen-filled light bulb in 1953, 1960, a laser, 1962, the first visible spectrum LED, and 1980s, Philips sell the first compact fluorescent lamp as an alternative to filaments, sulfur lamps, and then in the 1990s, a real landmark, the first lamp lasting longer than 60,000 hours. In 1994, the fluorescent lamps produced more than 100 lumens per watt, which is a real milestone in efficiency. But in 1995, LED developments led to the first practical commercially viable LEDs, the start of the boom that we're in now. So LEDs are a new type of lighting. We've used artificial light for perhaps 70,000 years in the form of torches, and we can now see that the LED was invented less than 100 years ago, but the first commercially viable one only 25 years ago. So with more rapid improvements in LED technology in the last 10 years, the increased efficiency of light sources has, depending on one school of thought or not, seen the proportion of global energy consumption due to lighting reduced from around 25% to 15%. Already a long way along the path. LED lighting is now the dominant technology in almost all forms of lighting design, and an obvious choice for designers of modern installations. And the two principal reasons for this are efficiency and life expectancy. So let's just compare this to more traditional light sources. The efficiency is discussed in terms of lumens per watt. The lumen is a basic unit for measuring brightness in the same way that a gram measures weight. And as we buy energy in watts, the efficiency is measured in lumens per watt. So let's look at the relative efficiency of various types of lighting that we may be familiar with. The ordinary incandescent lamp, our old-fashioned 60-watt bulb, 50 to 20 lumens per watt, depending on manufacturer and their data sheets. Low voltage halogen, 15 to 20. Halogen incandescent, from the 1950s onwards, up to 35 lumens per watt. Compact fluorescents from the 1990s, 40 to 80 lumens per watt. Conventional linear fluorescents, around about the same. The sodium vapor lamp, a big move up to 150. And white metal halide, around about 65 to 115. But the most efficient LEDs now, exceeding that, 135 to 150 lumens per watt, and rising at a very rapid basis. If we look at the same list of light sources and look at life expectancy, we see the second reason why LED lighting has become so attractive. There are a number of ways of measuring this and a number of scales and grades of viewing it. So this is a simplistic view. Ordinary incandescent lamp, 1,000 hours. Low voltage, 2,000. Halogen, 2,000. Compact fluorescent, 8,000. Linear fluorescent, sodium vapor and metal halide, 10 to 20,000. but the most efficient LEDs, 50,000 and rising. And again, rising at a great rate. And if we look at this graph, we can see that the more conventional light sources, high pressure sodium, metal halide, fluorescent, all sort of went through a development period in the middle part of the 20th century and flattened off in terms of their efficiency and their stability. But look at the green line of LEDs. Developed in the 1960s, very, very slow process. And then all of a sudden in the 1990s, 1995, an almost vertical increase in efficiency. So we're now heading comfortably towards 200 lumens per watt in commercially available light sources. So how do we use this to approach net zero? There's a good reason for going through the background information. It helps us understand more about the varying range of efficiency improvements that we can make by replacing existing lighting with LEDs. We'll see this spans a broad spectrum, and I want to explain how we can make decisions about changing from older technology to LED. And the first example to look at is a quite simple like-for-like change, seeing what LEDs can yield in terms of efficiency. So let's look at what happens when we take a very straightforward halogen floodlighting installation to equivalent LEDs and compare the equivalent transition as though they were metal halide lamps. So the starting point is a small church nave currently lit with 10 floodlights. So here's our £25 floodlight, 10 of these, typical lamp power 300 watts, lamp life around 1,000 hours, light output per lamp 5,200 lumens. And for our calculations, let's assume that the church is lit for 20 hours a week, or around about 1,000 hours a year. And it's not dimmed, so it's running at 100%. So from this, we can calculate 300 watts, a quantity of 10, 20 hours a week, 52 weeks a year, 3,120 kilowatt hours. In terms of total light output, 5,200 lumens times 10, 52,000 lumens. So the lumens per watt divided by 300 is 17.3 lumens per watt for the installation. Now, if we replace those LEDs, those fittings with LEDs at 150 lumens per watt, then the increase in efficiency works out to be almost 90%. It's a massive saving in terms of energy. And the actual energy saving across the year would be around 2,750 kilowatt hours. Now, if we take a typical metal halide version, the equivalent to the 300 watt, which would be around about a 70 watt metal halide, lamp life is 10,000 hours rather than 1,000 hours. And the light output for our 70 watts is still about 5,500 lumens. It's not a dimmed system. Let's say it's running over the same amount of time. So the equivalent savings, if we go through the same set of calculations, is an energy saving of 47%. But because we started off only running 728 kilowatt hours, the saving is only 342 kilowatt hours compared to 2,750 from the halogen. So there's a much different grade of level of saving if we switch from halogen to LED compared to switching from metal halide to LED. So some older forms of lighting are more energy efficient than others, and a simple change to the equivalent LEDs will not always yield the same energy savings. So let's look at how to achieve the most effective efficiencies. If we go back to basics, the goal is to reduce our carbon footprint. Immediately reducing energy is the key. And the transition to more energy efficient light sources like LEDs is clearly an obvious step in the right direction. However, the most important point to take away from this is that more effective use of any lighting system can yield energy savings if carefully managed. So let's look quickly at a case study that shows the results of an LED upgrade in a church that has both pendants and spotlights. We'll come back to more examples later, but this is Christ Church, New Malden. Original installation, all halogen, carried out in 2007. Typically, the settings were dimmed at about 60% and running at 7,500 watts. After the complete LED upgrade, the typical running level was about 1,200 watts. So again, we're seeing an energy saving of around 80%. And a typical running cost, depending of course on what we pay for the units of energy, is around £2,000 a year. So what's the most effective way of reducing our energy use? One very obvious method of saving energy is to turn lights off when not needed, or if there's an option of dimming, turn them down. Our eyes are amazingly sensitive, but still typically don't register reductions of intensity of light of less than 10%. So a small reduction in dimming can make a saving in energy. Try to use only the level of light required where it is needed. The more we understand about different types of lighting that we use and how we control them, the easier it will be to achieve the goals of reduced energy use, reduced carbon footprint, reduced running costs, and reduced maintenance costs. And this leads to sustainable, low cost and effective lighting, and ultimately towards net zero. What are the other factors that might need to be considered? Well, the use of light in our churches, of course, is more complex than just lighting the nave. And it's not just a simple engineering exercise. So let's look at what other factors might need to be considered. The ceremonial use of light occurs in many religions, from the golden lamp of the Acropolis of 300 BC to all the meanings that we understand in today's liturgy. And as well as being a functional tool, light creates a sense of warmth and welcome. We need to examine how we want the light in our churches to impact on the look and feel of the building and to support and enhance its ambience and the theatre of the liturgy, but also to understand the technical implications. The Church of England has recently commissioned the formalisation of new advice on the approach to new lighting projects, which is entitled Lighting Guidance for Cathedrals and Large Major Churches. The guidance deals with a wide range of topics associated with project governance, management, design development, review, installation, commissioning, etc. And where there is more than just a simple exchange of fittings, this will help most users understand the wider factors to consider. But unfortunately, the release date is some way off. The guidance hasn't been confirmed as the programme has been disrupted by COVID. However, we can review the key points of guidance. There are some straightforward questions we can ask to understand the nature of the process. Does the existing lighting provide the correct amount of light in all the right places? If yes, a simple upgrade should work. If no, maybe simple changes could be made to accommodate deficiencies. If not, a like-for-like upgrade might not be possible or satisfactory. Are there any planned changes in the use of the space that might impact on this? If no, a simple upgrade again. If yes, perhaps changes can be made, but if not, a like-for-like upgrade may not be possible. Would it be practical to simply swap the existing fittings for LEDs that do the same job? If yes, a simple upgrade should work. If no, again, changes may need to be made. And it's just trying to understand what these changes might need to be. Some questions are a little more complex. Is the existing electrical infrastructure and its controls in good condition? A recent electrical inspection report should answer this. If yes, again, a simple upgrade should be okay. If no, there might need to be some remedial works or some more substantial electrical repair works. Is there a simple switching system or are there dimmers already installed? Simple switching, very easy to upgrade, but dimming may not be an option. If there are dimmers, they may need to be removed or replaced. Compatibility between old dimmers and new LEDs can be a problem that needs to be understood. And any complex electrical repair works may mean a like-for-like upgrade may not be possible or satisfactory. But overall, if the wiring is in good shape and there are no problems with the controls, then a like-for-like upgrade should be possible. So if the answers to all of the above have been positive, a straightforward upgrade should be okay. And the next steps would be to carry out an audit of the existing lighting, hours of operation, assess or take advice on the complexity of the project and decide who's best placed to draw up a scope of work and manage the process. Check that all of the right people have been consulted along the way. Consider the cost, energy savings, disruption, running and maintenance costs, and consider the life cost of the installation and its ultimate replacement cost in future. And also take advice on the need for approvals. Is the work list A, list B, or does it require a faculty? If all of this is clear, then you should be able to plan to implement the project. Approaching a more complex situation, what's behind the asterisk in satisfactory? Perhaps the existing lighting design is lacking with insufficient light in key areas. Maybe there are significant electrical repair works. Are there existing dimmers that cannot control new LED light sources? I'll come back to that later. So a new control system might be required. Is the church now being used for different purposes, for concerts, community events that may require more or different lighting, perhaps in different areas? If the situation is this much more complex, you may need to refer to these new guidelines and certainly take professional advice. So rather than approaching it as a straightforward upgrade, you may need to consider an emerging need for a new lighting arrangement with new fittings in different locations and/or new controls, a new project. So how do we approach this? These questions and answers should help the decision-making process. Firstly, project governance. As I say, you'll get all the slides for this, so I won't go through in all detail, but essentially you've got to make sure that you understand the whole scope of the project that's to be done. Who's going to do the work? Who's going to manage it? Who's taking responsibility for its implementation? Also, question of design. To ensure that new lighting will support the core function of the church, as well as being an effective and sustainable solution for the long term, you need to make sure that other requirements are understood. Can the congregation read in all the seating areas? Is the seating movable? Is there sufficient focus for those leading the liturgy for all types of services in all forms? Is the pulpit used? Is the lectern always in the same place? Does that get relocated for different types of service? Are there other points of focus for worship leaders, music groups, or other presenters? And are there additional points of focus for weddings or baptism? And is the church used for wider community functions, perhaps bringing in income? Is there adequate light for musicians and choirs? Is there sufficient flexibility of control? And then there are technical considerations, which might include what type of new fittings are required, where should they be located, how should they be controlled, does the wiring system need changing, do the dimmers need changing, what regulations, standards, codes of practice, etc. should the work comply with. Wanted to come back to lighting control in a bit more detail. Many older systems use basic light switches. Lights are simply turned on or off. Dimmers in their simplest form appear with rotary knobs or sliders and allow for manual control of lighting levels, but do not allow for any form of presets. Traditional larger dimming systems with multiple circuits use centralized dimmer racks that allow you to reduce the voltage to a lamp for specific circuits and create presets or scene setting. Most theatres, concert halls, multi-purpose venues will have had systems like this in the past, although many will have now been upgraded to accommodate more modern LED systems and their controls. Many LED light sources are able to be programmed electronically now with onboard dimming, meaning that large centralized dimming racks are no longer required, and there's less hardware and systems are less expensive. Other than the aesthetic and practical benefits of being able to preset and balance lighting settings for different purposes, this is also the start of being able to use programmable dimming to control and manage energy use. The energy savings are remarkable, with the reduction in energy being typically proportional to the level of the dimming. 50% of dimming, 50% of energy use. So dimming systems should be seen as an important step on the road to net zero. Another important tool is to use movement or occupancy sensors. For a church open to visitors during the week, an automatic system that turns lights on to a simple preset when a visitor enters and off when no one is left in church provides an enormous saving. This avoids having lights on all of the time and means that a visitor setting can be tuned to highlight the key points of an interior rather than having too many lights on for too long. A programmable system might also take account of changes in external and ambient daylight. In the summer months, there may be perfectly adequate light, and the only lights really required for the visitor might be a subtle highlight to key features such as the altar, the font, or wall paintings, for instance. But in the winter, there may be a need for general ambient light so that a visitor can see their way around what might be an unfamiliar space, box pews, chairs, etc., easy stumbling blocks. So here there's an important criteria for safety, as well as creating a sense of presence in the church. Managing illumination levels is the absolute key to reducing energy consumption. If lighting is switched, there's no capacity for attenuation or dimming. But with a dimming system, a 10% overall reduction in light levels will directly result in an equivalent energy saving, which our eyes will probably not notice. Equally, our eyes respond well to variation in levels of visual contrast. This means that we're sensitive to relative levels of light rather than just levels of intensity. Thus, we can see that an object such as an altar is highlighted if it's brighter in relative terms than its surroundings, which means you might just need to light the altar, not the whole space that it's in. So if the chancel or sanctuary is relatively dim, a subtly lit altar can still be seen to be highlighted without being overlit. Zoning and grouping is another way of making sure that energy savings are optimized. It's important to identify lighting elements at relative light levels, and it's also important to have the flexibility to control different areas separately or independently. So this means that, for instance, downlights might be at 50%, depending on the time of day or night, but lights in the welcome area might be at a higher level for the notice boards. The points of focus, such as a lectern or pulpit, might be at 70%, but wall paintings, the light level might only need to be 20 just to bring a little light to enhance them, and uplights could be as low as 70%. Just briefly talking about some of the more common technical pitfalls, and I know these will probably come up in the Q&A session later. Dimming has enormous benefits that lead towards energy savings, but there are difficulties in trying to control LEDs on different types of dimming systems. Whilst there are many mains dimmable LEDs, as they're referred to, which can work on conventional dimming systems, there can be problems of compatibility between some older types of dimmers and these dimmable LED lamps. There are different types of mains dimming systems which are designed to control transformers for low voltage halogen lamps, some for wire wound magnetic transformers, and some for electronic transformers. All mains dimmable systems, and we have many mains dimmable LEDs, but these systems work in quite different ways, and most dimmable LEDs will only work with one type and not the other, and the type varies. Another common compatibility problem is that mains dimming systems have a minimum load criteria, which means they need a load of, say, 50 watts for the system to work properly, but a replacement LED lamp might only be 10 watts. And this is where we encounter low load flicker, or the LED lamps not actually being fired by the dimmer. Modern mains dimming systems are now being designed to operate with lower loads down to 1 watt, which can help with the LED retrofits. But older systems simply cannot go down to that low power level. So if you already have a dimming system installed, it is essential to establish what type it is and to carry out a thorough test to see if new LEDs can be controlled effectively. And if you are considering a new dimming system, you need to understand what the options might be. So many LED light sources have onboard dimming. And to make the situation more complex, manufacturers have produced various different forms of controlling this onboard dimming, which may be wired systems, Bluetooth, mesh, RF technology, and you may hear or read of names such as Zigbee, Kasambi, Galaxy, others too, all competing to be established as the standard for lighting controls. But you could say that we're in a battle similar to that was called the first format war between VHS and Betamax in the 70s and 80s. The battle went on for many years, with VHS being the victor, even though it was a low quality system than Betamax. The key points here are to understand that the lamp or the light source has to be controlled by a device normally referred to as a driver, and the driver is controlled by a control system. But these three components are likely to be made by different manufacturers, all very keen on selling their own products and not too fussed about endorsing anyone else's. So if a new system needs to be designed, the designer, installer, somebody has to ensure compatibility across the whole system. And this is where you may need to bring in some professional advice. Here's a simple summary of the most common problems associated with LED upgrades. Retrofit lamps are a square peg technology into a round hole. Some retrofit, most halogen lamps are the same color of 3000K, but LEDs can vary enormously from a warm color to a very cool color. And there can be a problem if LEDs of different colors are mixed in a space. Metal halide lamps also have a narrower spread of color compared to LEDs. Flickering can be caused by incompatibility with older or newer dimming technology. Quick note on the color of light. One of the characteristics of LED light sources is the increased ability to choose the color. We've all seen the difference between warm white and cool white. Typically, the light in an industrial environment will be cooler or bluer, more clinical, whereas domestic and social environments tend to be lit with warmer, more yellow or orange colors. Here's candlelight and daylight. Why is this important? Well, LED light sources are more efficient if they're cooler. For example, a spotlight at 4500K, the middle color here, may be around 15% more efficient than the same spotlight with a warm white 3000K light source. Sorry, that's gone wrong. But the additional brightness of the cooler light source may in certain circumstances make the less easily visible, as the harsher color of the cooler light may make the natural colors less easy to distinguish. Look at some case studies quickly. All Saints at Carshalton, carried out in 2006, again all halogen, typically ran at about 60% with almost 13 kilowatts of electrical load. After the 2020 upgrade, the dimmed level of around 40%, because the LEDs were more efficient than halogen, around 2000 watts. So an energy saving again of around about 83%, and a typical saving of £1,600 a year. Christchurch, New Malden, we've looked at already. Again, very simple halogen to LED changeover. Methodist Central Hall, originally lit with halogen lamps, and in uplighting the dome, 24 kilowatts. After an upgrade to fluorescent light, which was dimmable, the energy saving was 90%. And as using the building for 60 hours a week, energy cost saving £10,000 a year. Now, I've just brought that in because it's not about LED. That's about going from halogen to fluorescent before LEDs were available. St John the Evangelist in Blackheath, the first all LED lighting scheme installed in Southwark. Total maximum load 3,000 watts with everything turned to full. It's usually dimmed down to 40 or 50%. Testing after 5 years showed that the lumen depreciation, the sort of the wearing out of the LED light sources, was less than 2%. Again, there was an energy saving of 90% when it was installed, and the estimated cost savings over a 10-year period of around £20,000. A quick look at external lighting. Most of the above arguments and rules carry forward on external lighting, but the essential differences are that most existing non-LED lighting is metal halide rather than halogen, therefore relatively more efficient in energy terms. A metal halide lamp life is generally longer than halogen, so potential savings are less. You have to work harder to make the savings. External lighting is generally only switched, so making energy savings through dimming, a new dimming system may need to be installed. One of the drawbacks, though, of metal halide lamps is the colour shift over time, so changing to LEDs is always an improvement, providing the colour choice is set correctly at the design stage. 3 key technical problems to look out for. To ensure the replacement power output is equivalent, not only can buildings become too bright or too dim on a changeover, but planning restrictions may apply to overlit exteriors. Nobody wants to receive an enforcement notice, so it's very important to get calculations of illumination levels correct. LED floodlights tend to have significantly different optics or beam control compared to their metal halide predecessors. They work in a completely different way, and care needs to be taken to make sure that the replacement floodlights and spotlights have the right beam angles as well as power output. So simple lamp change is rarely possible. Ecological restrictions apply to sites that bats inhibit, and specific requirements that can be applied may be less easy to comply with some LEDs because of the variations in colour. So take advice if you need, because consequences can be profound. I didn't show case studies of external lighting, but I can mention that floodlighting at the Tower of London has been converted to LEDs over the last 5 years from metal halide. And generally, the energy savings have been going at about 80% because of a significant reduction in illumination levels that was deemed to be appropriate. So the energy savings here on such a large scale have been seen as a great success, some 200 to 300 floodlights, I think. The White Tower of the Tower of London was in fact the first LED conversion for floodlighting at the tower. 1,000-watt metal halide fittings were replaced with 100-watt LEDs, achieving an instant energy saving of 90%. Finally, St Michael and All Angels in Blackheath, London. The spire, the Needle of Kent as it's known, seen for many miles in a number of directions. Here a new floodlighting scheme has been installed with ground level uplights, lighting to the clear story and the tower and spire. Maximum energy consumption of 1,500 watts, which is typically run at about 40%, meaning that the actual running load of the whole installation is around about 600 watts. The ultimate energy saver. As a last point, I just want to revisit the most obvious energy saving technique. Turn lights down or off. If we turn it on, we can turn it down and turn it down further and turn it off. Thank you very much. Lovely to have some questions.
Thank you very much, Bruce. You know your stuff, don't you, Bruce? Looking at the Q&A. So everyone listening in, if you've got a question that hasn't been covered by the slides, please pop it in the Q&A, and also have a look through the other questions that are on there, and you can click a thumbs up next to the ones which you'd like to see answered, and they will move naturally to the top. So the first question there at the moment says, when you are citing the efficiency of LEDs, are you including the power dissipation in the power supply, which halves the efficiency? Yes,
that's the data we've given has been based on the total output of the luminaire system, not just the chip itself. So the energy losses of drivers have been taken into account. I'm not sure that halving the efficiency is the right number. I think probably a number of manufacturers might argue with that, but drivers are very variable in quality from different manufacturers.
Then, so the questions at the top at the moment says, what is the carbon footprint of light sensors running continuously compared to the efficiency saving the form of lighting? So I think that means kind of the embodied carbon in putting in place the sensors.
Yes, I must say I don't know the answer to that one.
No.
Again, there are many different types of sensors. There's a tendency to migrate towards wireless sensors that are used for occupancy rather than light sensors. But my understanding is that light sensors are passive, and therefore their energy comes from the light that's applied onto the sensor.
A question from Richard: when looking at your average church, if such a thing exists, what is the typical percentage of total electrical energy used for lighting? Just trying to sense the significance.
That's a really good question, and I think I know the answer to that, because I mean,
let's see if we've got the same figure.
Many years ago, and this is before LEDs, I did a piece of work for a diocese to try and assess where the money went in energy use, and we calculated, working with others, that lighting would take up approximately 80% of the cost in a average church, if indeed an average church exists. But of course, the more square meterage is taken up by parish rooms, offices, halls, etc., the more that may shift. And of course, a big factor is whether or not there's electric heating. But typically, of an electrical installation with non-electric heating, 80% of the energy goes to lighting. And
if you look at the analysis of the church energy audits, and that looks at both gas or oil and electricity, then the vast majority of a church's energy use as a whole is on heating. But obviously for most of our churches, that's gas rather than electricity. So looking across energy use as a whole, lighting was actually only about 6%. But nearly all of the energy audits, so it was over 90% of the energy audits, did recommend making improvements to the lighting, because it's relatively simple to make changes compared to heating. And there's a relatively quick payback on the changes that you make to lighting. So the energy audits would say relatively small slice of the energy use as a whole, but a really important area to focus on because you can make changes.
So I should have said that my answer to that was based on the proportionate use of electrical energy, not energy across the board.
So the next question is about faculty. There's list B covers the installation of lighting equipment and extension of an existing lighting system. Do you think either of these cover upgrade to LED lighting? So this is very much to you with your hat on as
yes,
CAC advisor.
Okay.
What can churches do, list A, list B, and what do they need faculty for?
This is a really tricky thing, because list B allows for extensions to a lighting system, as Peter's put in the question there. And it also includes installation of lighting equipment. However, and this is the thing that, I mean, certainly I've seen as a DAC advisor on a number of occasions. There hasn't been, in some instances, there hasn't been a lot of thought given to the color of LEDs. So we talked about cool white as opposed to warm white. And there has also been a very simple assumption that you can take down a fitting and replace it with another one, and it should be able to go through under list B. And I think technically that's both correct. But I think where guidance is still necessary is just that watchful eye to say, have you got the right amount of light in the right place in what you're doing? Which is why I went through a lot of the questions I went through. And the key thing, I think, in faculty terms, does it require a faculty? It comes back to the point, does the work impact on the internal aesthetic of the building, which is the DAC's overriding, responsibility. So I think that carefully executed good LED upgrades should be able to go through very comfortably as List B, and that should be encouraged because it's a fantastic energy saving opportunity. But I think one has to be very careful, particularly in listed buildings, to make sure that the changes done are still in keeping with the aesthetics and the character of the space. And that, I think, is a very easy line to cross. And that's where I think people do need some help to make sure they're doing the right thing.
And where would you generally recommend that churches turn to if they do need that that kind of help and advice?
Talk to your architect, talk to the DAC, and particularly, I think most usefully is talk to other churches and colleagues that you know who've had systems done in similar buildings. You know, if you're responsible for looking after a grade 1 listed building or a 2-star listed building, don't look at what's being done in a 1960s construction. Look at something that's being done in a building of similar age and character, and just make sure that what you're going to get is actually what you need to have, what you want to have.
So the next question is almost a philosophical one about net zero, which says, if you're using a renewable electricity supplier, does it matter that much which light source one uses? So I would say yes, it does, because
it costs you less.
If
in running terms, yes.
If you are on a renewable tariff, but other buildings aren't, if you waste a unit of renewable electricity that you could have saved through having inefficient lighting, then whilst you might be on a renewable tariff, that unit of electricity is no longer available in the grid. And so someone else who's on a brown tariff will get their electricity, a higher proportion of their electricity probably from a gas-fired power station. So we always focus on making real reductions in energy use as the most effective thing you can do environmentally. Absolutely switching to renewables as well, but you want to make real reductions in your energy use as well, not just switch it and then waste it. The follow-up question from Richard, who asked the previous question about what proportion of energy was used in lighting. Interested in your views on smart metering in this context. Don't we need to have this sort of real-time information on energy use to be able to identify the current draws and the savings associated with any changes? That's slightly wider than lighting, but
yes, it is a bit wider than lighting, but information, I think, is always useful. However, if you were going down the route of some digital control systems, they include monitoring systems embedded within the controls themselves. So it'll tell you what's happening very much in the same way that a photovoltaic cell installation will tell you what it's doing. I'm not sure that it's essential. It may be more useful and interesting in terms of documenting savings than helping you achieve any further real savings, but I think that's down to the user, really.
Question from Sarah about external floodlighting. Can they be dimmed? And if not, can filters or baffles be applied?
Well, metal halide floodlighting can't be dimmed. Well, I mean, there's a very complicated system for doing it, but it really didn't take off at all. LED lighting systems should be able to be dimmed if you make sure you have dimmable light sources. Can you attach filters or baffles? Filters on LEDs, well, I think if I understand the question correctly, to reduce light level, yes, you can apply filters to reduce light level, but you're not saving any energy by doing that. You really need to be reducing the energy at source if you can.
And then the next question is from Alison, and actually this links to a question in the chat, which was about the cost of installations. So you gave some really useful case studies which said how much that they were saving per year, but how much did those installations cost roughly? And more generally, how long is a piece of string in terms of lighting projects?
The payback period, of course, depends on the amount of time that the building is used. And it also depends on whether or not it's simply an entirely like-for-like exchange, and whether or not any additional facilities are being brought in. So both at Carshalton and New Malden, there had been sort of slight reordering changes in both churches, and therefore the capital cost was increased by adding new lighting in new locations, as well as just doing an LED upgrade on existing. But I would say that the payback period is a period probably between 10 and 20 years. It's not going to be more rapid than that, but it is going to get closer to net zero much quicker.
And if you talked more generally about the cost of lighting projects from at one end, simple LED replacement, to at the other end, a whole new system, what can you usefully say? I know it's so case by case, but
simple LED upgrades, it depends largely on the cost of the fitting that you opt for. And I mean, I think the words of caution are, you need to make sure that the fittings that you are buying are of a high quality that are going to last for the period of time that they should be lasting. I do know of a number of LED upgrades which have been done quite simplistically with quite low quality fittings which have failed. And I noticed that Stephen Craven has asked a question about reduction in lumen output. Poor quality LEDs have quite rapid, what's called lumen mortality. Not very nice phrase, but that is the way that light output from LEDs depreciates over time. 4 years is a very, very rapid time period for there to be LED lumen depreciation. So the more expensive, more expensive fittings are going to be of better quality and last longer. Coming back to your question, Catherine, I think that a simple LED upgrade might be a few £1,000s in a small church, but a project in a cathedral is going to be hundreds of thousands of pounds because of simply the number of fittings, the amount of cabling, the time duration. The building's got to stay open, the contractors have got to work around. Behind me is a Catholic cathedral where there's masses during the day. Contractors have to stop and start work a couple of times during the day, all that sort of thing. So it starts off at a few £1,000s and it goes up and up and up depending on size, complexity, and the type of lighting that's going to be installed.
Thank you. The next question is from Roger Joyce. Cost will always be a consideration for small congregations. How do we cover the question of ultimate cost saving versus initial capital cost? Any loans or grants available?
I'm not really in a good position to talk about loans or grants. That's not our area of expertise. I think loans and grants tend to be better sourced locally. So I think start with Archdeacon and DAC secretary and work around from there. But there are a number of bodies, I think, that do particularly support energy saving initiatives and are prepared to fund electrical upgrade projects that will save energy. But I'm afraid I can't give much more information on that, I'm afraid.
Put in the chat a link through to our grants directory, which includes a section on environmental projects. They are all competitive, but at least you might find some ideas in there. And the other website I would keep an eye on is Community Energy England, and I'll put a link into there as well. They keep a very useful page of funding opportunities live on their website. Often that's more about kind of solar panels, but they do have some which are broader. And I guess the other thing is looking at the funders who will fund conservation projects, but including within that elements of energy efficiency when you're doing other projects. The next question from Colin says, what about embodied energy? Similar to the question about the controllers earlier. What about embodied energy? Some of the upgrades were carried out after a short time. So is there energy of the jettison scheme and the energy of the new installation?
Trying to figure out what the question is there in terms of has it been considered in terms of the energy calculations? No, the energy in the jettison scheme has not been considered. It'll be the disposal of the electrical case, sorry, the metallic casings of the light fittings, essentially. So I don't think there's a great deal of embodied energy in that. But I should also say that, you know, one of the other great motivating factors behind LED upgrades is maintenance. And halogen light sources and halogen schemes from the 90s and early 2000s, the life expectancy of a spotlight fitting of that era is not a great deal more than 20 years. And therefore, and that's largely because of the heat the fitting builds up over, you know, time, and it deteriorates and you get scorching and arcing in the fitting, etc. And so a lot of the motivation behind doing it is because a lot of the fittings are coming to the end of life. I mean, you know, we always, you know, talk with contractors about making sure that fittings are disposed of appropriately. There's the WE directive, as it's called, in terms of the disposal of electrical equipment, to try and recycle. And it's also worth saying that the B Corp process now, a lot of lighting manufacturers are following into B Corp, where they're making the bodies of light fittings as sustainable as possible and as renewable as possible, so that the life of the light fitting itself is extended as far as possible. So it's a better product, effectively, to try and use.
How are we doing? We've got 1 minute left. Right, let's go for Kathy's question, which is at the top. This is back onto faculty permission. A church I know locally wanted to move to LED for internal lights, submitted to DAC as the colour of the new fitting was slightly different. This was not approved. Are there plans nationally to prioritise sustainable improvements and be more flexible, as this is a climate emergency? I mean, we can't comment on that individual case. I mean, in general, the faculty process, people need to make their case, and it would seem.
I think what I would say there is if the colour of the new fitting is different, you know, if you're going to put a white fitting up instead of a black fitting, then that's the sort of thing that I think a DAC would look at and say, well, that's not actually a like for like replacement. And I think the idea of List A and List B is to try and encourage like for like replacements to happen very easily. But where it's not like for like, I think that, you know, there can be some questions raised, and that may be part of the reason. I certainly flag up in cases that I'm asked to look at, what is the color temperature of the light that's proposed? Is it the same color temperature as is being replaced? Does the parish realize that they may be going down a route of changing from a warm white light source to a cool white light source, and they just haven't seen or understood that that's what's going to happen? So I think that, you know, there are a couple of safety checks in the list that I've gone through today that might help that sort of case.
But from the amount of information I've got there, it's hard to say anything. But if I say more generally, the faculty system absolutely takes account of the benefit of making environmental changes. If something changes the aesthetics of the building, you'd have to make your case. Church would have to make its case about why the change they wanted to make was needed through their statement of needs. And something like a minor change in the colour of a fitting, I wouldn't expect to be an issue if the benefits of the case are clearly made. Having not looked at that particular case, I can't comment really on it any further. It is 1 o'clock. We've got a final, so let's just take this final one also from Kathy, which is about the cost of scaffolding. Is there anything more of a statement than a question, really? Any advice about
yes, I mean the reality is contractors will charge for scaffolding that they have to erect to make the work safe. Again, this comes back to the planning of the project, and for instance, talking to the parish architect about, is there any maintenance that needs to be done at high level? Do the clear story windows need inspecting? Is there any work to the roof that could be done at the same time? Can we make more effective use of having scaffolding or a cherry picker or a scissor lift in the church? We're going to put up some new lighting. Can we make better use of the equipment whilst it's there? That's a very common way of trying to make the most of an inevitable cost of access equipment.
And I've certainly heard of churches investing in higher quality fittings and lamps higher.
Yes.
And then where they needed to, saving some money on the ones that are easier to access.
That's right, yeah.
So that they only had to get scaffolding up very occasionally for maintenance at the high level.
Yeah. I can give an example. A church near Guildford, which had a very, very high nave, and the only place to light the pulpit and the lectern were actually from a very awkward position to get to high up in the nave. So we put double the number of fittings up on 2 different circuits, and when one lamp failed, it was actually more cost effective just to have another lamp to turn on than to bring in scaffolding to change individual lamps. And I think that tactic actually worked well, because that was probably done about 20 years ago, and only now are the church looking at doing an LED replacement.
What a very interesting and practical point to end on. Sorry, Colin, I can see you've got a couple of things there left unanswered, but we have got to the end of our time. Thank you so much, Bruce, for coming along and speaking to us today.
It's a pleasure. Thank you.
As I said at the beginning, there's one more date of Bruce's lighting webinar. So if you've got to the end of this and wish the colleagues had heard of it, please do send them the link to the webinar programme and ask them to come along to our heating webinars and our other topics that we've got coming up. The video of the lighting webinar should be on our website in the next few days, and I will email you round Bruce's slides later today. Thank you very much for coming along.
Thank you.